In this video, I want to draw stack diagrams for a couple of short C programs to illustrate how multidimensional arrays work in C and to introduce the string library. The first C program, which I will try to show here, demonstrates two different ways that we can make a multidimensional array. Lines 5 and 6 of the program declare the variables that will point to these two different arrays. Both of these will be dynamically allocated arrays, and so we keep track of them with pointers. And we initialize both of those pointers to null. Then on lines 7 and 8, we call malloc to make the initial allocation for each of these arrays. The array of arrays variable is of type int star star, which means that it is a pointer to an array of int pointers. And so on line 7, we are allocating space for 3 int pointers. Malloc creates some space on the heap and then gives us back a pointer to what it allocated, which we are assigning into array of arrays. And so now this pointer points to the beginning of our array of int pointers. On line 7, we're allocating a single chunk of memory with enough room to hold our entire 3x4 array. When malloc allocates a chunk of memory, we get a bunch of consecutive addresses, but here we are going to pretend that those addresses that are all sequential in memory are laid out in a 3x4 grid. But since the actual addresses are laid out linearly, we are going to have to do the work of keeping track of which cell corresponds to what row and column. Lines 9 through 15 are a for loop that will fill in both arrays with the same values. And on line 10, we are allocating one of the inner arrays for our array of arrays. So on the first iteration of the for loop, r is 0. And so we assign into the 0th element of the array of arrays the return value of a call to malloc. We are now mallocing space for 4 integers. And so after this assignment, the first int pointer now points to an array of 4 integers. Then the inner loop will fill in the first row of each array. On this first iteration, we will calculate r plus c equals 0 on lines 12 and 13. And line 12 is getting the 0th entry in the array of arrays, and then putting the value in the 0th entry of that array. While line 13 is computing 4 times 0 plus 0, so we are accessing index 0 of our single allocation, and we put the value here. Then we come back to the top of the inner loop and increment c. And now we are accessing index 1 of both arrays and putting the value 1 into both of those entries. And as we continue the inner loop, we will fill out the rest of the first row in each array. Then we return to the top of the outer loop and increment r. And then on line 10, we are assigning into element 1 of the array of arrays the result of a malloc call. And now in the inner loop, we are still filling in r plus c. And so when r is 1 and c is 0, line 12 will access index 1 of array of arrays, and then it will access index 0 of the inner array and put the value 1 here. Then on line 13, we will compute our index into the single allocation as r times 4 plus c, so we will go 4 entries into this block and put the value 1 in this location. When r is 1 and c is 1, line 12 will access index 1 of the outer array and index 1 of the inner array and assign r plus c equals 2. And line 13 will calculate an index of 4 times 1 plus 1, so at position 5 we will put a 2. The remaining iterations of the inner loop fill out the second row of each array. Then we return to the top of the outer loop, increment r to 2, and arrive again at line 10, where we will call malloc and assign the result into index 2 of the array of arrays. Then in the inner loop, we'll initialize c to 0 and compute r plus c equals 2, which gets filled into index 2, 0 of the array of arrays. And in the single allocation array, we calculate the linear index 4 times 2 plus 0. So at index 8, which is this position, we will fill in a 2. And then, likewise, the inner loop will fill in indices 2, 1, 2, 2, and 2, 3 of the array of arrays, and the indices 9, 10, and 11 of the single allocation array. So this gives us two different ways of representing a dynamic multidimensional array in C. We can either malloc for each level of the array separately, or we can malloc one big block to store the entire array. One advantage of the array of arrays approach is that indexing is easier. On line 12, we can just give r and c as the indices to the outer and inner arrays respectively. Whereas for the single allocation version, we have to calculate the linear index into the block of memory ourselves by multiplying the row number by the number of elements in a row so that we know how far to skip before we start indexing in with the column index. But the single allocation approach has the advantage of requiring a lot fewer mallocs and therefore also a lot fewer frees. When we're done with our single allocation array, we can clean it up in just lines 16 and 17, where the call to free will deallocate the heap memory, and then to make sure that we don't follow a bad pointer, we can set that pointer to null. But if we were to call free on our array of arrays, that would deallocate only this chunk of memory, and we would lose our pointers to the inner arrays, and so those inner arrays would be leaked. That's why instead, on lines 18 through 20, we first loop through and free all of the inner arrays before we free the outer array on line 21. So this loop will deallocate the first inner array on the first iteration, then the second one on the second iteration, and the third one on the last iteration. And at this point, we have a bunch of dangling pointers, but that's okay because we are about to clean up this chunk of memory as well. So on line 21, when we free the array of arrays, that cleans up this. And then line 22 sets the pointer to null to make sure that we don't follow it to invalid memory. And this is our state at the end of the program. In our second program, which should now be visible here, we have some local variables right from the start of main. As we've seen before, argc and argv as inputs to main tell us, respectively, the number of command line arguments and the actual strings that were typed on the command line. So to trace through this program, we'll need to give some command line arguments. If our executable is called a.out and the program were run from the command line with /a.out some args, then we would have an argc value of 3. And argv is the array of strings that represent each of those command line arguments. Argv is of type char star star, so this is using the array of arrays representation. If argc is 3, then we know that there were 3 command line strings, and so argv will point to an outer array that has pointers to the 3 strings. So at the beginning of main, we already have the value 3 in argc and argv pointing to an array of pointers where each of those pointers gives us an array of characters, and those arrays of characters represent the strings that were typed on the command line. Note that all of the arrays of characters end with an end of string character, and that argv ends with a null pointer. We'll talk more later in the semester about why we need this null pointer. And now we can start tracing through main, where on line 6 we set len to 0. Then we're going to iterate through the command line arguments with a as our index variable, and on each iteration we are calling strlen, passing in an element of the argv array. Strlen is one of the many functions provided in the C string library, and it takes an input of type char star, so we are giving it a string. And on the first iteration, we are passing it the 0th element of argv, so we are giving it this character pointer, which means that its argument will point to the same place that argv of 0 is pointing. So we have given it a pointer to the start of the a.out string. The strlen function then has to iterate through the string until it gets to the end of string character to figure out how many characters are in the string. We're not going to trace through the function, but in fact you will be writing your own implementation of strlen and many other string functions later in the semester. And eventually this will give us back the number of characters in the string. This first string has 1, 2, 3, 4, 5, 6, 7 actual characters before the end of string. And so line 8 will add to len the length of this string plus 1, so len becomes 8. Then on the next iteration of the loop, a is 1, and we pass to strlen element 1 of our argv array, so it will tell us the length of this string, which is 4, and so we will add 4 plus 1 onto len, giving us 13, and then on iteration 2, we'll get the length of this string, which is 4, so we'll add 5 to len and get 18. On line 10, we are declaring a character pointer and making it point to the return value of a malloc call. And we'll get enough room for 18 characters. Right now, we have no idea what is in the memory that was just allocated on the heap, so we represent that by blank boxes. But on line 11, we call strcopy, passing in our pointer to all args and a pointer to the a.out string. Again, we're not going to analyze strcopy in detail, but we should think about what arguments we passed in. The destination string that we gave it as the first argument was the all args pointer, so we copied this address, which is pointing to the heap, into the function argument. And the second argument, the source, was copied from argv0. So we took this pointer, copied the address into the function arguments. And so again, we have a pointer to the start of the a.out string. Strcopy will loop through this array and copy characters one at a time until it gets to the end of string. And so by the time it returns, it will have filled in the characters of the source string, including the end of string character, to the destination chunk of memory. Then lines 12 through 15 are looping through the remainder of the arguments and calling the strcat function. Strcat, again, takes a destination and a source, and the destination we gave it was all args. So it has a pointer to the beginning of this array. And the source that we gave it on line 13 was the string literal with a single space. And so the character pointer that it received for the source is a pointer into the code segment of our program where we have the string literal with a single space followed by an end of string. The strcat function will scan through the destination until it finds the end of string, and then it will begin copying characters from the source until it gets to an end of string. So the end result, when strcat returns, will be that we have added a space and an end of string to our a.out string. Then strcat returns and this stack frame goes away, after which we call strcat again and get a new stack frame for strcat, where we are passing in argv of 1, so we are giving it a pointer to the beginning of the sum string. And so that will find the end of string character and then start adding the characters of sum until it gets to the end of string, which is also copied. The next iteration of this loop will again concatenate twice. It will first concatenate a space, and then it will concatenate the string args, with the end result that we have filled up our dynamically allocated all args array with all of the command line arguments separated by spaces. We then call printf and get a stack frame for printf, which will print out this string. Of note, if we had gotten our calculation of the length wrong, the string library functions don't know how big the destination is, and so they could easily have run out the end of the space we had allocated. But due to our careful use of strlen, and also adding the +1 to account for the spaces and the end of string, we had enough room, and so we will succeed in printing out all of the arguments. Then on line 17, we free our all arguments string. And on line 18, we set the all args pointer to null to make sure that we don't access invalid memory. Over our next few programming assignments, you will get a lot more practice with all of the topics we covered today. On homework 6, you'll be allocating and manipulating multidimensional arrays. On homework 7, you will be implementing your own version of many of the string library functions. And on homework 8, you will be implementing the creation of new processes, which includes setting up the argv array. And you now have all the tools you'll need to analyze the C code you'll be writing using stack diagrams.